This video gives a brief introduction to circles, which are one of the basic conics we will cover in this unit. Please take notes on the examples in this video. There are two forms for writing equations for circles. The first is the more useful of the two, and it's called standard form or center radius form. The reason that it's helpful is because in the form, we can actually see the center of the circle and the radius. It will be equal to whatever the radius is squared. So for example, if this is 25, we would know from that the radius of the circle is 5. We've seen this HK before when we've studied the vertices of our parabola, when we've put it in vertex form. So the idea is similar, except that HK, our center, is not actually a point on the circle, it's the center of the circle. The other form is general form, and this is a form that can be used to represent all four of the conics that we will study. In some of the forms there are additional terms, but in general this is the general form. In order to convert from this form to standard form, you're going to need to complete the squares, which I'll do later in the video. We did that earlier on in the year, but I wanted to refresh your memory on that. Let's look at some examples. The first example asks us to sketch a graph of this equation, which is fitting the standard form for a circle. Now that I've written the standard form, I can see that h must be 3 and k must be -2, because this is technically y minus k, which must be y minus -2. I can also see that this number is the radius squared, which means the radius must be 4. That's all the information I need to graph this, so let me set up my sketch. So I've plotted the center at 3, -2, even though this is not a point on my circle. It's not actually a part of the solution points, but of course it's helpful in graphing it. From here, I'm going to go up, down, left, and right 4, and that should be enough for me to draw in a sketch. So I go up 4, put a point, down 4, from the center, put a point, and left and right 4. So here's a sketch of my circle. And it's worth noting that every single one of the points on this circle satisfies this equation. What that means is, for example, I have the point 3, 2 here. So if I were to put 3 in for x, up here, sorry, and 2 in for y, when I solve this out, I would get 16. The same thing would happen when I put in the point 7, -2. I put 7 in for x, -2 for y, sorry, up here again. And when I solve this, it would again be 16. That would be the case for every single one of the points on this circle. Each point satisfies the equation, meaning it gives a true statement when substituted in. Let's look at a second example. Here I'm asked to write an equation for each circle described. And the first one gives me the center, so I'm definitely going to use my standard form, the x minus h form, because I know h and I know k. The other piece of information I need to fill in that form is r, and while I'm not told r, I am told the area of the circle, and from the area of a circle we can of course get the radius, because the area of a circle is pi times r squared. So here's my standard form. I'm going to fill in -2 for h and 1 for k. And I actually have r squared right here. R squared must be 24. So I'm going to replace r squared with 24. And that's it. I'm done. So here is the equation for the circle that has a center at -2, 1, and whose radius is root 24 technically, because when I square it, I would get 24. In the second example, I also have the center, so I'm going to immediately substitute that in for h and k. But then I'm also not told r, and that's the other piece I need. However, I am told a point on the circle. And as I mentioned in the last example, every point on the circle would satisfy this standard form. So if I fill in my h and my k, and an x and a y, the only variable that will be left here will be r squared. So let me substitute those in now. So here I'm going to fill in x minus h. In that case, that's 1 minus 5, which will be squared. And then I'm going to fill in y minus k, which will be 3 minus -1, and I'll square that. Now I'll simplify the left-hand side of this equation, and when I do, I'll have what r squared equals. So 1 minus 5 is negative 4. When I square that, I'll get 16, positive 16. 3 plus 1 is also 4. That's coincidence. Squared is 16. So 16 plus 16 is 32, so it looks like r squared is 32, and that's the last piece I needed. I have my h and my k, and I have my r squared, so I can fill them all into the equation. So here's my final answer for the equation for this circle. The last example we're going to look at requires me to complete the square to put the equation in the correct form, so I wanted to go through that process. Completing the square helps me to get a trinomial that will factor into a perfect square binomial. And if I have a perfect square binomial, that is fitting my standard form for a circle. So to complete the square, you always take half of whatever the coefficient of the x term is here. So half of b would be b over 2, and you square it. And that is what goes here. Whatever I add to this side of the equation, I'm going to have to add to the other side of the equation, which I'll show you in the next example. The last piece I wanted to remind you of is whatever the half is, so b over 2, that's what gets put into the binomial that's going to be squared. So now I have my perfect square binomial. So this will always be the half of b, as you can see written down here. Let's look at an example. So here I'm asked to write this equation, which right now is in general form, in standard form, which will help me to see both the center and the vertex. The first thing I want to do is group my x terms together and my y terms together and move this positive 8 over to the other side, so it will be negative 8. Okay, so I've grouped my x terms together. This is the number that this is going to be b over 2. And I've grouped my y terms together. This is also going to be the second b over 2. I actually have to complete the square twice for this, once for the x terms, once for the y terms. And remember, I can't just randomly add something to one side of an equation, so whatever number I add here, I'm going to also add here, and similarly for these two. So as I mentioned, I would take half of the coefficient of the x term, which is 6 over 2, or 3. I'm then going to square 3, and that's 9, and 9 is what gets added to both the left and right-hand side of the equation. I'm also going to write down that the half, which remember was 3, is what gets filled into my binomial. And so now I have turned this trinomial into this perfect square binomial. If I were to expand this out, I would get x squared plus 6x plus 9. And I'm allowed to do that because although I added 9 to this side of the equation, I did the same thing on the right-hand side of the equation. I'll now do the exact same thing with the y's. So I take half of my b term, which is negative 4 divided by 2, negative 2. So I now know that going inside the parentheses will be y minus 2, and that's going to end up being squared. There's my perfect square binomial. And then I take that half, negative 2, and I square it. So that gives me positive 4. I add that to the left-hand side, and immediately I add it to the right-hand side. And the last step is to clean up the right-hand side. Negative 8 plus 9 is 1, plus 4 is 5. So I have done what I was asked to do, which is to write this equation in standard form. I can now see the center of this would be at negative 3, 2. That's my h and my k. And r would be, careful with this, the square root of 5, because this term on the right is r squared. That's it for this video. Of course, we'll do more examples during class. I hope you found it helpful.